So to integrate with polar coordinates, we need to find the area element. I'll remind you what the area element looks like in Cartesian coordinates. So we have a box, we have a dx and a dy, and this gives us a little dA. In polar coordinates, our boxes look like little pieces of rings, like this. And we have a little d theta and a little dr. This is our dr, change in radius, and this is our d theta. So the area of this box is going to be our area element, and we need to find the length of the other side. This side's dr, and this angle's d theta. And the length of an arc is the angle times the radius. So this side, right here, is r d theta. So if dA equals dx dy in Cartesian coordinates, dA equals dr times r d theta, or put slightly different, r dr d theta. Let's do an example where we use the area element to integrate. Okay, so we want to convert the coordinates to polar coordinates and integrate f equals y over the region depicted. So the first thing to note is that the angle here is 60 degrees. You can see that from the 1√3 triangle. And the angle here is 120 degrees measured from the x-axis. So theta in this region is between pi over 3 and 2 pi over 3. Those are those angles in radians. And r is between 0 and 2. That's the outer radius there. Okay, so we have our rectangle in polar coordinates. Now we want to integrate f over this region. F is going to be y, which is r sine theta. And our area element is r dr d theta. And then our radius goes from 0 to 2. And our theta goes from pi over 3 to 2 pi over 3. Okay, this is an integral that can be split into two integrals because the function can be written as a product of functions of r and theta. And this works out to be r cubed over 3, 0 to 2, that'll be 8/3. And this works out to be negative cosine theta, pi over 3 to 2 pi over 3. So this is 8/3, and this works out to be negative a half. Cosine of 2 pi over 3 is negative a half, so negative negative a half minus, and then cosine of pi over 3 is 1/2, so minus minus 1/2, which is 8/3. Let's do another example. So our region is this quarter ring, and our function is x squared plus y squared. If you look at the change of coordinates, this is just r squared, because x is r cosine theta and y is r sine theta. Our area element is r dr d theta. Our limits in terms of r are from 1 to 2, and our limits in terms of theta are from 0 to pi over 2. This can be split like before. So 1 to 2 r cubed dr, and 0 to pi over 2 d theta. So this works out to be r to the 4th over 4. And this works out to be pi over 2. This is 16 over 4 minus 1 over 4. So 15 over 4 times pi over 2, which is 15 pi over 8.